Awesome. I feel better about myself instantly. All right, we'll give a few more minutes for people to creep on in here. All right, so a couple of housekeeping notes. There will be a hackathon sponsored by Engine Yard. This is also the company that has Deus under their portfolio. So on the third day, there will be a hackathon, and you'll be able to create charts for Helm and get other ideas about how to extend and build things on top of Kubernetes. So if you're sticking around for the third day, be sure to attend the hackathon. There will also be a couple of lightning talks as well on the third day. So just some housekeeping notes there. And there'll be a sign up upstairs. So around lunchtime, look for the sign up if you want to participate in the hackathon. So it looks like most people are here. And we'll go ahead and get started with our next talk. So our next talk is Cloud Surfing, Kubernetes on Mesos. This is a talk I'm really looking forward to because this is a very interesting concept. So let's give a big round of applause to our next speaker, Karl from Mesosphere.
Check, check. Yep. Now I need a computer that's working. Yeah, that happens. There we go. Hey, magic. Technology, how does it work? All right, so this is Cloud Surfing. I'm Karl Isenberg. I work at Mesosphere there. And a little more about me. I work on Kubernetes on Mesos. And previously, I worked at Pivotal on CloudFoundry and BOSH, all the things. And before that, I was at Williams-Sonoma doing e-commerce platform stuff that hosts way too much traffic during those Black Friday days. You can find me online, it's not too hard. So, the cloud, did your eyes just glaze over? Because this is kind of a scary slide. Really, there's a lot of tools. The landscape here is really kind of confusing. When you're just coming in, you want to deploy application, like what tool should I use? Should I use a PaaS? Should I deploy right on my IaaS? Should I use OpenStack? Why is OpenStack running on AWS in this? I don't know. People do crazy shit. So what you really want to do is be like Renton here. He's a cloud surfer, and I, with my long hair, have never surfed a day in my life, but cloud surfing is what I aspire to. So what you really want to do is Gabe, get to know a little bit about a lot of tools and a bit about a little bit of tools so that you can dig deeper when you need to. You want to stay as high level as possible so that you can use your API that makes the most sense. You want to use your application APIs when you're writing applications. You want to use service level APIs when you're writing services. Or you want to go down a level. You got to dive deeper, dig out another API down in the trenches, and then you really want to stay loosely coupled, that is, when you're hanging 10, because the looser you are, the more flexible you are. You're going to get APIs that are going to change. You're going to get implementations that don't work for you at any given time, and you need to end up switching things out. You're going to end up mixing and matching tools in order to get what you need functioning. So you want to stay on top of it all, but you don't want to be too locked in. So tool selection is hard. There is no one tool that solves all your problems, no matter what the sales guys tell you. You want to pick the right tool for the job. Everybody knows this. This is kind of one of those memes that traffics around. Everybody has heard it before. But picking tools is hard. So you got to pick tools that do one thing. Philosophy there. And the reason that's important is because large APIs are hard. When you have a huge API set, you can't change it, you can't re-implement it, it's hard to change. Did I say that already? And you, basically you end up stuck on this API. So you want to have different layers of APIs where your APIs are small at each layer. And you want to chain your tricks together. You want to figure out which piece is best at what and put it together with this other thing that's best at something else. You often get tools that will try to be good ends up being as bad at everything. So you want tools that will focus on a certain area and compromise in some other area. It's not because you don't need that other area, but because you want this tool to do this one thing, and then you have another tool that is better at that other area so that you can link them together. So a lot of this is kind of common knowledge, but it takes a lot of work to the cloud landscape to know what's really going on. So I'm going to break out some atmospheric layers here. I like putting things into buckets. People like seeing buckets. So we're going to start with the IaaS layer. This is machine management. Everybody knows about IaaSes. We got AWS, we got vSphere, OpenStack. Got lots of people that will give you a machine. Your machine is your box. You can spin up multiple of them. Doesn't really matter what you do with them. The IaaS layer doesn't care. Layer on top of that is provisioning. So there's a lot of tools that will provision basically putting things onto your machines. Your machine is this empty box, and it's not very useful unless you have some kitchen sink on it, like say Ubuntu. So you end up with provisioning all of your software on top of these machines. These tools might be easy to use. They might just do one machine. They might do a cluster of machines. You got to figure out which ones are good at what. Next layer up is resource management and process management. Mesos is the prime suspect in this category because it handles your resources. You have an API that asks for CPU and memory and disk space, and it has a process, and it runs that task to completion or until you stop it. There's a bunch of other layers that will do similar things, but usually they end up being in this tier above, in the containerization tier, that will give you a bunch of resources. You have caps at how much CPU you want, caps at how much memory you want, and it'll bucketize these together. Docker and Rocket are the prime candidates. Garden, CloudFoundry implementation, and Mesos has its own containerizer that predates Docker, but you can also use Docker on there. Those containerization layers are usually single machine. So Mesos, the layer below, will handle multi-machine resource management. Containerization is usually single machine management. And then above, not everything above it is built on top of job scheduling, but job scheduling is ideal for things like one-offs, for chaining, for running a distributed cron. Kubernetes does job tasks now, barely. Kronos has done this for a while on Mesos. There's some other competitors in this that will run these. And then the layer on top here is container orchestration. Container orchestration is definitely what you're using when you're using Kubernetes. Kubernetes asks you as a user to provide multiple containers, to chain them together. The same could be said of Swarm, Fleet, and Marathon, Lattice as well. There's some definitely hosted solutions that are similar. And this is sort of the layer above that provides containers across multiple machines, scheduling across multiple machines. And then we have yet again another layer on top. This is the application layer on top. I like to think of this as the as opposed to the container paths. CloudFoundry and, as we saw, Dcos do application source code management. They do lifecycle of your application itself. And that's a little bit different than container, because with Kubernetes right now, you have to bring your own lifecycle management for your source code. Container, it'll lifecycle manage your container. So there's a whole lot of tools here, and most web app developers want to use the top level. They want to use the highest level application they can, or API tier that they can, so that they do the least amount of work, so that they re-implement all of these things that have already been implemented in the cloud. And that's great if you're an application developer, but not all of us are application developers. I'm a framework developer. I like writing the lower level tools. That doesn't necessarily mean that I can't use a container orchestrator, but I'm probably not going to use an application layer on top. I'm going to peel back the layers so that I can write Kubernetes, for example, in order to figure out the right layer for me. So in order to figure out what layers for you and play with them and discover them and manage these tools, because all of these things have their own life cycle. Your applications aren't the only things with life cycle. Your Mesos and your Docker and your Puppet, all these machines down at the bottom, they all have their own life cycle, and something has to manage those things. Otherwise, you're in a mess. Because these are basically the pets that are managing your cattle. Your cattle's up at the top. One of these has their own little quirks. Some of them can be containerized, but not all of them. Some of them really need to talk lower level. Depends on the situation. So at Mesosphere, we work on the data center operating system, and this is sort of a wrapper for the operating system tools you need in a cluster. There is a kernel, Mesos, handles your lowest level task process resource management. Then there's Marathon as the init system that handles your containerization and your scheduling of tasks. And then there's also a package manager that will install things. This isn't necessarily your application layer package manager. This is your framework layer package manager that lets you install all of these complicated tools. So I'm going to demo here, and it looks like I'm the first live demo. And to crank up the suspense a little bit, I am running leading edge head of master code that just came off of CI, and I have no idea if it's the same code that I tested last night. So let's clean this up a sec. OK, I have a DCOS cluster running here. It takes a few minutes to boot up. So another thing I already did was install the DCOS CLI. It's not too hard. You can follow instructions down here. I'm not going to go into that right now. However, the cluster itself was deployed with CloudFormation on AWS. This is the community edition version of DCOS, so it's available to everyone. You can just go to mesosphere.com/product and follow the links to install your own. This happens to be a 6-machine cluster on AWS with 5 private and 1 public node. The reason for private versus public is because you don't necessarily want your services all exposed. All of your things are on your cluster. The reason you would want to have a giant cluster like this, 6 nodes is huge, huge, would be to install multiple tools. So we statically partition your DCOS cluster to whatever size you want, and then the tools that you install on top of it dynamically allocate up to as much resources as they need. So I'm going to install, I already installed Cassandra because that takes about 6 minutes for the gossip protocol to kick in. But I'm also going to install etcd right here and Kubernetes. I feel a little sorry for the Diaz guy going on and on about how hard etcd was to get working in containers because, yes, installed. So this is a Mesos framework, and it has a framework piece that's running in a container on top of Marathon. Marathon dies, it'll respawn it. We only need one of that because that's our backup and our scheduling. etcd doesn't schedule all the time. It only schedules when it comes up and then reschedules if one of the nodes go down. So if the node goes down, in this case we're spinning up 3. If the node goes down, it'll bring it back up automatically, replug it into the cluster. Have to have special containers that do that automatically on boot. So now that I have etcd, it says unhealthy. What it really means is booting. I'm going to configure my Kubernetes to talk to that etcd. And then I'm going to install Kubernetes. Yes, I'm aware this is an alpha and might break on me on stage. So now I have Kubernetes. It'll take a second to spin up. We can watch it spin up, but it's similar to etcd. We have a framework running the master components inside of Mesos on Marathon, and those will be kept alive, and if those go down, the whole thing can be restarted, and all of the data is in etcd, so etcd will just persist it for it. And so we don't actually need a highly available Kubernetes unless you want highly available traffic talking to your Kubernetes, which we're definitely working on. But for now, it has recoverability and fault tolerance. So Kubernetes is there and idle because it doesn't have anything running yet. With the cluster here, we're going to get a UI and a DNS that come normally with Kubernetes. And hopefully we can see those by clicking on this. It says the UI is not up yet, which is not surprising because it's at idle and not finished. But there's the UI. So right now we only have 2 pods running on Kubernetes, so it's only on 2 nodes. It's automatically created the kubelets for these to run with the proxy by scheduling those as a Mesos executor on the Mesos node. So I have 6 Mesos nodes. I only have 2 kubelets right now. And we can see that that'll ramp up as I deploy more things. So now everything's healthy. We're going to go on to the next phase of the demo. Next phase is a little demo app that I wrote. It's really not that exciting, but it's Twitter. And it's Twitter backed by Cassandra. And it's replicated 3 times. I could replicate it more, but 3 is pretty good for the traffic I'm going to be submitting to it in this case. And it's backed by Cassandra on Mesos. So Cassandra that I booted up previously has 3 nodes running. It's highly available the same way etcd is, except etcd you want to usually talk to the master. Cassandra you can talk, and you set up your application for a replication factor. Says I want a certain number of copies of these. I want to talk to a certain number of nodes to make sure I have all the information that I want. But since we're Twitter, we don't really care about like highly consistent. I could scale this up to 5 or more nodes of Cassandra, and it would be able to pull as data as it has available and show that to the user. And we have discovery of Cassandra via DNS. Mesos DNS is kind of cool because it doesn't just do DNS, but it has its own API layer. So if you know how to talk to Mesos DNS, you can pull back the tasks that are running on Mesos by name. And of course, it's in GitHub. So switching back here, one more thing that I didn't cover already. We have a plugin. I told you I had the Dcos Cli downloaded in. Voila, now I have the kubecontrol already installed too. It just downloaded that from the Kubernetes running on Marathon with the correct version and passes through all of the arguments to it. Yep. Is that better? So I have down here a YAML file with that may not be big enough to see. So this is pretty cool. It's just got my Oinker app with some arguments that pass through to tell it to talk to Cassandra and tell it that I want a replication factor of 3. And it's running on HTTP, and I'm passing in an environment variable to get the name of the node that it's running on, the pod rather. Also using a service up here to give it port 80 service. This allows me to route it through the API server proxy without setting up a load balancer separately, because in this particular version we don't have ingress points yet. So we don't have the load balancers externally implemented as a controller yet. But great. So let's shrink that down again. Nice thing about this YAML file too is it's actually a service and a replication controller in one. So I just do one command and done, magic. To prove that that actually did what I think it did, I'm going to print the pod list. It says one of them is running and ready and the others are pending. So we're going to open up the Kubernetes UI over here in a new window. We can see I've now three more kubelets and put a pod on each one. And each one of those is getting usage statistics. And since this UI is actually being used through the same system, I can just switch over to the default namespace and the Oinker, and I have Oinker running. So I'm pretty sure most of these are up, but let's double check. Looks like they're all up and healthy, and they all came up in the first restart, so that's cool. And now we just have this backed by Cassandra, magical, not all that complicated. Went back to the server, stored that in Cassandra, redirected, rendered the new page again. We can see here, or maybe you can't, that I'm running on this particular node. And I can reload the page here and get a different node and show that it's still. And then, now that I'm feeling a little more risky, I'm going to spam it with some oinks. And this is just pulling the Dcos config and getting the cluster for the kube control and parsing out the URL, converting it to a URL that it can read based on what I just did in the browser window, and then it's just running a for loop in bash that just does wget to the endpoint. It's effectively a form post, yada, 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 yada. I have lots of yada yadas. Now for bonus, I know for a fact this will not work as planned. I'm going to scale this up to 18 replicas, or at least try. There is a particular bug that will tell me to schedule correctly, and it will eventually schedule. It'll get there. We can go back to the UI. We can see node grids, see how much each is using up. We got some resource graphs here. Those are a little hard to see, probably. That doesn't really help, does it? So now we're going to check these pods out again. Let's see how many we have, whether they're running. Think. Let's try one more time. There we go. OK, so I got a bunch of them running, but not all of them. We can just do a word count over here. 13 running, I told it 18. Those exit code 2 just means that it failed scheduling the first time, so it's going to retry. So this will eventually get up. But we don't actually need it to get up because we're load balancing these things. So I can keep going back to Oinker over here and hitting enter all I want, reload the page over and over and over, and I'm never going to get a 500 error from those ones that aren't running because they don't get load balanced too. So that's a pretty simple demo of what you can do with Dcos and Kubernetes on Dcos. Now for a little bit of a pop quiz. Were you paying attention? So what does Kubernetes manage? I can't see any of you, so I'm going to answer for you. Applications and services and jobs. Jobs is pretty new, but these are the applications levels that Kubernetes is really good at. It's the things that they aspire to. You heard earlier, they want it to work just for applications. They want people not to have to worry about the lower level pieces. So what does Mesos manage? Processes and resources down at the lower level. It's good at that. It already does that. It already scales. Scaling story that I missed earlier. We have a demo that we did with a Verizon earlier that shows 50,000 containers running on Marathon Mesos. This is not on Kubernetes, but we're working that. But we know that Mesos can handle that kind of scale, so we're working on getting Kubernetes there. So what does Dcos manage? Frameworks. You can install all of your frameworks on top of Mesos. Not all. I mean, obviously, you have to do some work to make them deploy on Dcos, but they run in containers on the cloud that you are running the rest of your stuff with. You don't have to statically allocate them. You have a standardized control plane that you can get to talk to them. As you saw, I just used the same URL for the UI that I did for Dcos. It's all there proxied. Cool. But you don't have to take my word for it. All this stuff is available and ready to use. I'll upload my notes into a gist later, but basically it's all there. You can find it online. The end. Oh, that's more than 4. Yeah.
You totally have no time for questions and answers. Tell them where they can find you, though, if they do have them.
On the internet. Just search for Karl Isenberg.
Awesome. Cool. Great. Thank you, Karl.